Welcome to the first Serverless London meetup of 2021. I hope you all had a good break over the holidays. I want to give a big thanks to Theodo and Senzo for continuing to sponsor the meetup into the new year. Senzo actually has two great courses starting soon. First up, they have Testing Serverless Applications, which is run by two AWS serverless heroes, Slobodan and Alexander. That's starting in mid-Feb. And then secondly, they have a Node.js for serverless course, which is run by the co-organizer of this meetup, an AWS hero, Ant Stanley. That's available from March. If you want to find out anything more about those courses, head over to homeschool.dev. But for today, we've got two great talks lined up. First, we have Ben Smith from AWS, who is talking about growing your serverless app. And then we have Taavi from Dashbird, who is going to talk about the well-architected framework through the serverless lens. After each talk, we'll have a brief Q&A session, so please put any questions you have into the chat as we go. But let's just get started. So Ben, you can take it away.
Thanks very much, Alex. I'll just go ahead and share my screen there. Thanks for passing over. There we go. So hide that. Thank you. Yes, my name is indeed Ben Smith, and I'm a developer advocate for AWS, focusing specifically on serverless. I've been with AWS for about 1.5 years now, and this session is all about the best practices for growing a serverless application. And what I think is kind of quite interesting about this talk is we're not going to focus so much on the technology of how to handle thousands of requests and scale up an application, but more on some of the sort of softer sides of your application, things like how to organize your code repositories, how to organize your development teams, how do you handle enforcing best practices in terms of security, how do you deal with managing multiple AWS accounts. So it's a bit of an unusual session, but I think a really useful one for a lot of people. And look out for this guy. This is Sam. He's going to pop up in a bunch of slides where you can use a link and the QR code to go to further information, blog posts, code repository resources, so you can dive further into some of the things that you think might be more relevant to you. Okay, so what we're going to do here is we're going to look at a sort of typical implementation of a serverless application built with Lambda that we sort of see customers, the sort of path we see them take. And we're going to use a typical story that we see from customers on day one when they're first discovering Lambda. And then we're going to fast forward to day 100 and look at some common challenges that we know our customers are falling into. And we're going to talk about how you can go about preventing yourselves from falling into some of those same sort of pitfalls and what you can do to prevent that. So a common story that we see a lot is that once a developer or a development team have experimented with Lambda a little bit, they've tried out some workload, maybe they've played with the event-driven model, and then they start to build their application prototype. Now, because serverless technologies let you scale and transition from prototype to production really fast, thanks to the inherent scalability and the managed infrastructure, before they know it, their application is running in production at scale. And they have this Lambda function that's receiving an event, and it's performing some computation on that event, and it's outputting the results to some destination, which, as we know, can be vast depending on the required business logic of your application. So fast forward to 100 days later, and as the usage of this application is increasing, maybe it's becoming more widely adopted, more successful, but it's now getting kind of additional feature creep. The developers now are having to keep up with this feature creep by building out their Lambda function to handle additional functionality. So this Lambda function is now needing to accept more inbound requests and process those requests and produce the outputs accordingly. So in an effort to keep up with this rapid demand on the business, our development team is resorting back to some old habits, and they're simply adding events to their Lambda function and then having to add additional logic to their Lambda function to process those events. And so on and so forth, right? So the good news is that the application, it's still operating nicely in production. The Lambda function is automatically scaling, it's meeting the demand, and the development team is still able to focus on coding new features without thinking too much about infrastructure. So what's the problem? What's the challenge here? Well, As more and more features are required and applied to this one Lambda function, the development teams are finding it harder and harder to decouple one request from another. And they have to now ensure that for every update or release, that it doesn't cause any breaking changes in previous releases. And so this is starting to slow down the release cadence now, and it's adding more and more complexity to this one Lambda function, because it now contains internal routing to handle each request. So what they've kind of accidentally done is they've created what you might call a monolithic Lambda function, or a lambdalith. Now, a lambdalith or a monolith in a Lambda function is not always a bad thing. I talk about this a lot when talking about using PHP and the serverless LAMP stack. It can be a good first step into serverless. It can be exactly the thing you need, but there are some challenges which you might want to think about if you build a lambdalith by accident, right? It goes hand in hand with this other growth challenge, which we see, which is that of a monorepo. So what started as a straightforward sort of single repository that was used to version control the function code is now becoming more and more difficult to separate the ownership of responsibility between the different development teams. And that's because there's no clear boundaries of ownership, because this code that sits in this Lambda function is not decoupled. It also means that new developers have to take more time to understand the complexity of this Lambda function, which is handling all these different events. And because it's all held within this one function, it's forcing every development team to use the same runtime, which is a whole other advantage of Lambda, that it's kind of runtime agnostic. So the bottom line is that this mono repo approach can cause some difficulties to maintain. So how do you solve these growth challenges of a lambdalith and a mono repo? So the first thing you can do is look to split your lambdalith, your Lambda function, apart into multiple functions. And each function should have a small, well-defined functionality and scope. So as a golden rule, you can aim to reduce complexity wherever possible by limiting the conditional logic in your Lambda function. And what you'll often see is a one-to-one mapping of an event invoke to a single Lambda function. And here's a good example of a common lambdalith that customers often end up building. So it might seem reasonable, and indeed sometimes it will be reasonable, to have an application whereby API gateway catches and routes every request downstream to a single Lambda function. And then in this Lambda function, it would contain logic to kind of branch internally to the appropriate piece of code based on that inbound event. So there'll be some sort of identifier on that inbound event, whether it's the type of event, the method, put, a post, or a get. Perhaps it's something in the URL or a parameter in the URL. And based on that, you will have the Lambda function code branching to handle that particular request. And again, that will work and it will scale operationally. But what it means is that the security permissions, the resource allocation, the memory allocation, and the performance is applied to the whole function. So what you can do is to split apart this function based on each CRUD operation. So by using the built-in routing capabilities of API Gateway, you can configure each request to route to a specific Lambda function. So this takes away the overhead of having to maintain routing logic within your Lambda function's code, and it reduces the complexity of the application, which reduces the scope of each Lambda function as well. So that allows you to then allocate the minimum required security permissions to each function, which is something we'll talk about in just a moment. So then by recursively applying this process to your Lambda function, you'll ultimately end up with lots of Lambda functions that are independent and reusable. And this reduces the impact of bugs or failures in one area of code that will affect other application operations, and it allows each function to scale independently according to its individual demand. What you can then do is to create microservices around these functions. So each microservice now becomes a kind of building block that, when combined with other blocks, makes up your application. And each microservice should deliver a well-defined set of capabilities around a specific domain. And then you can communicate between these microservices using events or using synchronous APIs. And this makes it simple to update and replace components without impacting the other blocks or the other microservices. So once you sort of getting used to this concept of a shareable, reusable Lambda function, there's challenges within that you might actually hit, where, for example, this one here, you have a Lambda function that's being used by more than one microservice. And this is normally not a good thing because it can cause a breakage and suffer from all the same problems that you get in a monorepo. So to avoid this as much as possible, you can follow a couple of kind of simple rules, which is to share the logic and not the function. So what I mean by that is that you might consider cloning this function and using one function for each microservice, or even merging those two microservices together. You should always use contract testing and versioning for your functions and assume that failures will occur. And then your Lambda function should typically be written for the good or the non-failure path. And you use other services to handle the failure path where possible, rather than writing code in your Lambda function to handle the failure. So as your microservices grow and your applications expand, then you start to need a reliable way to communicate within and between those microservices. And two great patterns for this is to use choreography or orchestration. There's modes of interaction with microservice architecture. So in orchestration, there's a controller or an orchestrator, and this controls the interaction between the services. And it dictates the control flow of the business logic. So that's responsible for making sure that everything happens on queue. And this follows the kind of request response paradigm. And AWS Step Functions is a great tool for that kind of interaction. Then you've got choreography, where every service now works independently. So there's no hard dependencies between them. They're sort of loosely coupled only through the events that they share. So here, each service listens for an event that it's interested in, and it does its own thing based on if that event was relevant to that service or not. It follows the event-driven paradigm, and for this interaction, you'd use something like Amazon Event Bridge. And more often than not, we find that you'll end up using orchestration to communicate within your microservices and choreography to communicate between them. So once you've created these building blocks, these microservices, you have these nice natural boundaries to group or identify your development team's responsibilities. And you can build repositories now based on these ownership boundaries and assign these to your development teams. Now, for functions that are entirely independent, like this one up here, this might not share any other AWS resource, so it might be appropriate for this particular function to be created as its own repository. So that could be something like a helper function or an event processing function. And you should use a framework such as AWS SAM, Serverless Application Model, or maybe the Serverless framework to help organize your code repositories. And there's a few different ways you can do that. So the first template here is using a monorepo approach, which might look like this, where you have all the resources and all the functions, all the event sources defined within a single template. Then you have your microservice-based model. So this allows you to create a repository for each individual microservice. And each repository then should have a single SAM template that defines all those resources and functions and event sources that are relevant only to that microservice. And in some situations, it might be necessary to have a function-based repository. So here, your SAM template would define all the resources and event sources relevant just to that specific function. Okay, another common challenge that you might face on day 100 is all related to security. So with the challenging kind of structure of a growing decoupled service application, you get these different new security challenges that arrive when you're moving from a more traditional application development approach. You have lots of resources now, so you have all these permissions to manage. Does having more resources mean there's more permissions to manage? How do you manage observability now into your applications across all these different regions and versions? How do you make sure that only approved code and secure code libraries are available to each function? So there's some of the questions that you'll face as you move on into your journey in serverless. And to answer some of these questions, you have to first change the way you think about security. So a more traditional approach to securing an application will look like this castle and moat approach. So here, you establish a hard, secure perimeter around all the resources or around the entire application that you are trying to protect. Whereas in a serverless application, you would use a zero trust model. So in a zero trust model, you establish these little micro perimeters which are built around each individual resource. And these perimeters will enforce strict verification of every single service and how they interact with each other. And the differences to each approach can be clearly seen in this sort of diagram here, where if you have a bad actor that breaches the castle and moat model, then they have access to that entire application now. Whereas with the zero trust model, if a micro perimeter is breached, then the access is still just limited within the bounds of that service. So it means the application as a whole remains more resilient to attacks or incorrectly assigned permissions. And this zero trust model is implemented using IAM, Identity Access Management Resource Policies, and execution roles. So in the case of Lambda, or a Lambda function, the resource policy is what dictates which events or services are authorized to invoke or to trigger your function. And then the execution role is what grants the function permission to perform an action with other services or resources. So essentially that dictates what the function is then allowed to do. And in this example, you can see that a resource policy is applied to the function, and this resource policy is allowing API Gateway to invoke it. And then the execution role in the red box allows the function to perform a put item action on a specific DynamoDB table. So the point here is that by using IAM roles to dictate the function's permissions, I'm able to decouple its security posture from its code and from its business logic. So that helps, again, to reduce the complexity of my Lambda function, reduce the code in my Lambda function, and also makes it easier to maintain. And I can go further with this still by creating something called a permission boundary. And I can use this to limit the scope of a function's execution role. So this can prevent users with write access from escalating an application's permissions beyond the scope of its own resources. So what that means is even if the function's execution role is granted additional permissions, they're only effective if it's also allowed by the permission boundary. So here's an example of how that looks, right? My permission boundary is the blue circle, and that's able to perform a put and an update on any resource in the EU West 1 region. And then my Lambda execution role, the orange box, is orange circle, is allowed to perform any action on a table called MyDBTable in any region. Now, the effective permission that this Lambda function is actually granted is to perform put or an update on that MyDBTable in the EU West 1 region. It's the intersection of those two boundaries. So if you scale this out across multiple hundreds of Lambda functions, thousands of Lambda functions, each one is now bounded by an application permission boundary, which is defined by some admin user. And with each has got still their own resource policy and their own execution role. But if a function permission is reaching beyond that boundary set by the application permissions boundary, it's still not authorized to perform that action. So this helps you safely scale out permission boundaries to multiple Lambda functions. There's a number of other services as well that you can use to help implement security best practices. So you have things like AWS X-Ray for monitoring. You have AWS Secrets Manager along with Parameter Store to hold your sensitive application data. And you have Lambda layers for allocating or sharing pre-approved code libraries. And what we're seeing is that as serverless adoption is continuing to grow, it's becoming more and more important to monitor for insecure flows and malicious attempts to force function into an unsafe code path. So that's why it's really important that visibility must remain decoupled from the application. One thing you can do that helps with this straight away is to tag functions to make them easier to track and group together. And you should try to use a combination of historic and real-time views, where historic views help to promote compliance, provide compliance reporting, and real-time views help to map out workflows and implement policies. And there is a really healthy, ever-growing sort of partner ecosystem of developer tools available to help you do this. And I think the next talk is by the CTO of Dashbird, who I'm looking forward to telling us all about how they do this and how they help us to secure our serverless applications as well. So keeping secrets in Lambda is really important, of course. Really, the key takeaway from this talk, I would say, is to use the AWS services where possible. Shift the responsibility of management onto the services so you can reduce your code and reduce the complexity of your Lambda functions. And that's the same again for this slide. So the idea, you don't want to place sensitive data in your code base because, and I've been guilty of doing this as well, just for testing while I'm developing something, putting an API key into my code or into an environment variable, thinking I'll put that later in a parameter store or something. And then you forget about it because it scales so quickly, you're in production before you know it, and you don't realize that ends up in a GitHub repository somewhere. So from the outset, use the services. You can do things like this. You can store API keys and secrets in something called AWS Secrets Manager. So that helps to also keep a single source of truth, which enables you to automate the rotation of these secrets. At that point, you don't ever need to know the value of that secret, right? So the example here uses a SAM template that uses an environment variable to hold the secret ID or a reference to that secret in parameter store. And then the box on the right here is where we retrieve the secret value from Secrets Manager in the Lambda function using the AWS SDK. So you'll notice the secret value is never visible. That's set in parameter store. Another challenge that we hear about a lot is managing business compliant code libraries and dependencies. So here, Lambda layer is the way forward. This can be used for instances where you have libraries that have to be pre-approved by your organization before you're allowed to use it. Or maybe libraries that are sort of custom built by your development team, which you want to share out across lots of different Lambda functions. And it makes the maintenance of code dependencies more manageable by keeping, again, this single source of truth. And what you can do is the use of these layers can be controlled with a layer permissions policy. So an example of that is shown here. This is using the AWS CLI to add a permission policy to a layer. And this particular CLI command is granting permissions for all accounts in an organization to use version 3 of a layer within their Lambda function. So it's a way of scaling out code libraries that have been pre-approved and sharing that amongst your development team using Lambda layers. Okay, fourth challenge is managing multiple AWS accounts. Again, another common growth challenge that we see. So microservice architectures typically results in a number of independent and loosely coupled services which are communicating with each other, either synchronously via their API or via asynchronously via events. And these microservices are often owned by different product teams, different development teams. These teams might segregate their resources into different AWS accounts for reasons of security or billing or resource allocation. And that can sometimes result in some different challenges, right? So this is where cross-account deployment is one. That's where you have a single pipeline that needs to deploy a microservice into multiple accounts. So for example, a microservice needs to be deployed into environments of dev and QA and prod, and all of them exist in separate AWS accounts. You have a challenge of cross-account lookup. So this is where during deployment, a resource deployed into one AWS account might need to refer to a resource that's being deployed into a different AWS account. There's cross-account communication where microservices that are executing in one account might need to communicate with a microservice that is already executing in a different account. So what do these challenges look like and how do we solve them? So first, let's take a fictitious airline booking app that consists of a number of different microservices. And we'll zoom in on the booking service and the loyalty point service. So these are communicating asynchronously using SNS. And the booking service needs to send notifications to the loyalty service when a booking's been made. And the loyalty service needs to then allocate the correct number of loyalty points to a user account and apply any reductions, so on and so forth. So let's say these two services exist in different AWS accounts and they're owned by different development teams. So how do you deploy this? you would use a separate deploy account as your central location. So this has your CI/CD services like co-commit, co-pipeline, co-build, whatever that might be. And the booking pipeline that deploys your booking resources, that executes in this deploy account. And it deploys the booking Lambda functions and all the related resources into that booking account. And then the loyalty pipeline also executes in the deploy account, and it deploys all the loyalty resources into your loyalty account. And this is what that CloudFormation template might look like in the deploy account to allow it to deploy booking resources into the booking account. So you can see that there's two IAM service roles here that are they enable cross-account activity. So both of these roles they actually exist in the booking account. And the first is a service role, which is assumed by CloudFormation when it carries out this change, set, replace action in the booking account. And the second is a service role that's assumed by code pipeline to execute this pipeline stage in the booking account. And this allows the access to code pipeline artifacts in the S3 bucket of the deploy account. So the next challenge, again, is cross-account resource communication. With asynchronous communication, it's a fairly common pattern in microservices where you have a publishing microservice that's sending events that consumers might be interested in without any concern for who those consumers may be. So in the case of this sample application, the publisher is the booking microservice, and that's publishing flight booking events onto an SNS topic, and that SNS topic exists in the booking account. Then the consumer is the loyalty microservice, and this looks up the ARN of the SNS topic at deployment time in order to set up a subscription to it. Now, we know it's bad practice to hard code resource names and ARNs into CloudFormation templates. So how can we achieve this cross-account stack referencing in a secure and repeatable way? There's lots of different ways to do this, by the way. As ever with AWS, it always depends, but one good solution is to use what's called a CloudFormation custom resource. And this is a special kind of Lambda function where whenever the custom resource is created or updated or deleted, CloudFormation uses the Lambda API invoke to invoke this Lambda function. And the function lists all the stack export variables from another account, and it returns these values to the calling CloudFormation stack. So what's great about this method is that it doesn't create a hard dependency between these two stacks. So your custom Lambda function or your custom resource is deployed using SAM, just like any other Lambda function. And that's deployed for the booking and air miles microservices. And the booking microservice is created by the booking SAM template and deployed into the booking account. And the loyalty microservices is created by its own loyalty SAM template and deployed into the loyalty account. Now, the loyalty template uses the custom resource Lambda function to return the ARN of the booking SNS topic. And the Lambda function uses an IAM role that's permitted to assume roles in another account. The custom resource Lambda function uses an SDK, or the SDK, to obtain and return the stack exports from the booking account. And here you can see how the SAM template uses the custom resource to subscribe to the SNS topic ARN. And finally, the permissions for SNS to invoke that Lambda function is granted by the Lambda resource policy that exists in the loyalty account. Now, that's a really tricky one to walk through on a PowerPoint presentation, but at the end, I'll send you links to the GitHub repository that contains all this code, so you can kind of follow through it at your own pace. So just to recap, there's some common challenges which we know our customers fall into when they are building out their serverless applications. And these challenges often occur, because of the rate of moving from prototype to production and keeping up with the demand of the business. So the first challenge is that of a monolithic Lambda function where you end up creating this tightly coupled code base that's adding complexity with all these different permissions assigned to this one Lambda function. And you can solve this by breaking this Lambda function apart into multiple functions to create nice, independent, reusable building blocks of sort of finite scope. And this same challenge comes hand in hand with mono repos, where it's really difficult to separate the responsibility of ownership between your different development teams. And you can solve this again by creating repositories around groups of functions or microservices and all the different resources that define that microservice. Then there's how do you enforce security best practices? And there's multiple permissions and resources to manage, where you use this zero trust model to help decouple your security posture from your code base. And then finally, managing multiple AWS accounts, where you have all the issues of cross-stack, cross-account deployment and communication. And Lambda custom resource is a really useful tool to enable this cross-account stack referencing. So it's well worth looking up. So thanks so much for your time. Again, my name is Ben Smith. If there's any questions that occur to you later on that we don't get to in this next couple of minutes, then please reach out to me on Twitter. My Twitter name is Benjamin_L_S. And this link here contains all the different resources and much more for this whole talk, lots of code samples, GitHub repositories, blog posts from all sorts of different people in AWS. So this is probably the most valuable link of the deck. So I'll leave that for a few seconds. And thank you very much for listening. I'll hand back over to Alex now.
I think I was muted. Thanks so much, Ben. That was a great talk. I've got a message from someone saying they were trying to ask a question, but it wasn't coming through. So I'll start with that. But if anyone else has any more questions, do feel free to send them through in the chat and I'll ask them to Ben. The first question was, with the multi-account structure, how do you share ARNs for things like Cognito, where you'd want that to be shared with pretty much all your different stacks?
Sorry, I missed the first bit. How do you what, sorry?
The question was, how do you go about dealing with shared ARNs for things like Cognito?
Yeah, Cognito is as much of a mystery to me as it is to most of our customers, to be quite honest with you. He wants to know how to go, or she wants to know how to go about sharing ARNs to the Cognito service.
Yeah, I'm imagining dealing with wanting to have a single Cognito instance, but having the permissions for all your different accounts all in a central place. Firstly, would you go about it that way?
The honest answer is I'm not sure about how you would go about configuring Cognito to be cross-account, but I can look into that. If you want to pass that person's Twitter or however they want me to reach out to them, I can look into that for them.
Yeah, I'll definitely put you in contact. They did give me a bit more detail, so I'll just ask. They said, because Cognito will be needed by multiple repos, do you just hard code it in the repos because it's a global dependency, or how do you deal with that?
Well, I imagine my first place to try would be to look at the custom resource of your Lambda function, which can output that, in theory, can output that ARN to whichever calling stack needs to use it. So that would be the first place I would look at. I don't see offhand a reason why that would not work for Cognito versus a different service. So I would say look at the Lambda custom resource that we looked at on the last piece of that session.
Nice, awesome. Well, no other questions have come through, so we'll jump over to Taavi now. But thank you again, Ben, for giving the talk. It was really informative.
Pleasure.
Talk to you later, Ben. Bye. Welcome, Taavi. I'll hand over to you now.
Hey. Thank you so much. Can you also share my screen? Awesome. I hope you can all see. Hello, my name is Taavi, and today we'll be talking about achieving well-architected practices and maintaining them for serverless applications. So my name is Taavi. I am the CEO and co-founder of Dashbird. I've been a developer myself for over 14 years. Unfortunately, I can't do it as much anymore as I would like, but I still day-to-day talk with a lot of serverless users, work with different organizations using serverless. And I've actually been doing this for over 3 years now at Dashbird. We're one of the leading serverless monitoring platforms. We work with over 4,000 developers, and we help organizations big and small who have built serverless applications and are running them in production to succeed, to take away the heavy lifting of implementing monitoring and security and well-architected practices. And we try to automate and abstract as much as we can from the process of enabling basically success. And I'm here today to give a talk about first to glance over the various aspects of the well-architected framework and kind of how we have arrived to it making sense for a lot of serverless users, and kind of what we recommend you think about. And then also on some of the real world challenges and how you would go about solving them, how we work at Dashbird with them, but also more of like trying to be general as possible, not to pitch the product, but just try to give you an overview of how you should be thinking about various aspects. So to start off, why should anybody care about being well architected? In our experience, there's 4 main things that it gives you, and this becomes especially important at a higher scale if you have customers that are relying on your infrastructure. So what we find is that it helps you build and iterate your products faster by giving you confidence and by enabling you to understand everything about your system more quickly. The other thing is being aligned with the best practices helps you mitigate risks and be more confident in the changes that you make to your applications. Or like the well-architected framework also pushes you to collect information and make informed decisions about your application. Also, it's a great resource for learning the best practices, and it gives you kind of the framework to maintain them over time, to continuously check for them and audit your infrastructure. So quick recap, the well-architected framework consists of 3 kind of core sections. First, you have the pillars. We'll go into that a bit later in the next slide, actually. Then we have the design principles, and then we have the questions. So for each of those, it's kind of a logical approach from top to bottom. First, what is important and kind of what are the areas you should be thinking in. Then how to design your infrastructure to align with the pillars and with the best approaches. And then the questions part is to give you the chance to evaluate and think about how are you performing against the pillars and design principles. So as I said, there's 5 pillars of the well-architected framework: operational excellence, security, reliability, performance efficiency, and continuous cost optimization. So let's go into all of these and kind of discuss a bit more deeply about what they mean, and especially in terms of serverless and why you should care about them. So the first one is operational excellence. In short, it means the ability to understand the health and activity of the applications, how your users are perceiving your service. And it comes down to gathering metrics, getting alerts, centralizing all of the monitoring data around logs, around metrics, around tracing, collecting metrics about business events, and getting this kind of a continuous understanding of your application and how different resources are performing. Then we have the security pillar. This pushes you to control the access to the application, access to data, access to assets, and it relies on kind of 4 things: identity and access management, detective controls. So kind of trying to continuously check for events that you should know about and the posture. It pushes you to automate security best practices and protect data in transit and at rest. Then there's also the reliability. So this really comes down to building the resilience into serverless applications. And how you do that is you build your infrastructure to recover and to be as transparent as possible in terms of failures, having a plan for recovery, being aware of the limits and the weak points. Then we have performance efficiency. So this comes down to using the resources efficiently and continuously optimizing the performance of an application, looking at different architectural choices over time on a regular basis, seeing if there's anything that's inefficient that should be changed, thinking about things like asynchronous patterns or synchronous patterns. And lastly, we have the cost optimization piece. So at scale, cost is a big challenge. Sometimes it's something you should be continuously monitoring, and you should measure the efficiency. You should understand where the changes are coming from, how much different parts of your applications are costing you, and the ability to detect changes and the kind of allocation of cost between different resources. So those were the 5 pillars. Just to recap, I didn't mean to go into too much detail here, but now let's jump into the real world and kind of how that translates back into actual customers using serverless. So there are 4 bigger challenges that we face when talking to our customers. And if you kind of think about it, those challenges really well align with well-architected practices. And if you are well-architected, if you are following those practices, then you should also basically have solved those challenges. The number one kind of source of problems, of challenges in our experience is getting visibility into an infrastructure, understanding how users perceive your system, getting the ability to interrogate data, to look at different types of metrics and logs. And the reason why this is with serverless, and I've gone through this migration myself as well at another company. So we went from 10 containers and a couple of databases into a serverless application that had over 500 functions. It had close to 100 different databases. It had queues, API gateways, and basically you end up with this this kind of a state of the application where you have the logic distributed across like hundreds of small pieces of logic or units. And the other thing is that you have logs, metrics, and traces for all of them. And that kind of together makes quite a challenging environment to work day to day and to understand what's actually going on across your infrastructure. And here we arrive at the second point. So when you have as much data, as much resources and complexity, then you're going to be spending a significant amount of time debugging, troubleshooting, making sure that when you make a change or you deploy something, that everything is still working. So we see a lot of our users sometimes spending too much time on those practices, and it's kind of an unsolved problem in some cases for our customers. The third part, and that's also from my experience as well as our customers' experience, is that when you have an environment of like hundreds of resources, actually each one of those resources is a point of risk. It can fail, it can have security issues, it can have a configuration issue, and it can stop working, or it can have a performance issue. And detecting those and maintaining alarm coverage, knowing that, hey, this happened here, is quite the challenge. And this is something you would have to implement yourself. And we see a lot of our customers struggling with just getting to know about, hey, I have a code exception in my function. I have something is wrong with my DynamoDB table maybe, or my SQS queue is full and there's a delay of a couple of hours. So all of those different unknown and known problems that kind of can happen. And the third part or fourth part actually is maintaining posture and best practices. So I think this comes down to a couple of factors. The first one is if there's a larger engineering organization that's adopting serverless, there's a lot of things to learn actually, and you might be using 10 to 15 to 20 different services, different AWS services. Each of those have your own kind of best practices, ways to work with them, and can have different challenges. So, maintaining security, doing changes, pushing new microservices that all follow those kind of best practices, and have your entire team align with those best practices is actually quite a challenge that we see organizations struggle with. So I think those are the main ones, and I think this is at the stage where you already have something in production. So I think when you're in the earlier stages, when you're just like building, you're in staging, you're testing it out. Though like the problems may be elsewhere, I think that the debugging and troubleshooting part is still really true, and kind of understanding the activity across a distributed infrastructure. But at scale, we see those four things really amplifying and becoming more and more challenging to engineering teams. So a bit about how your tooling should help if you're going to solve the monitoring and observability challenge for your infrastructure. And if you're going to build it yourself or you're considering a vendor, I think there are 5 things that are kind of the biggest levers, or the ones that if you solve, those are the most difficult ones, and definitely the ones that would give you the most efficiency. So I think the first thing is that since you have or your engineering team has a lot of resources and tons of monitoring data about them, you have logs, maybe in CloudWatch for Lambda, maybe you have something else like something in S3. You have different log streams, log groups across different services, across different regions, and sometimes without much structure. Then you have metrics, and then you have tracing data. Let's say you're using X-ray. So having one really efficient place to visualize, to interrogate, to query, to search, just basically a single pane of glass when anything goes wrong, or you just want to have an understanding of the current state that you can go to, you can interrogate and understand. And the underlying infrastructure for all of that would be managed, and you would have the ability to quickly access any type of data and correlate it. So this, we think, really benefits engineers in their day-to-day. It makes them more effective. It gives them confidence to make changes. And it's also really important in onboarding new developers to enable them to understand the application as quickly as possible, and to reduce the overhead that engineers would have to keep in their head. The second part that you should be implementing and hopefully automating is, and kind of in our case and opinion, the biggest lever in application monitoring at all is reducing the time to discovery and how fast you can understand the root cause of an incident. So that's really the biggest lever you can pull for a large organization that's using serverless or using any, or like building any type of application. The best thing you can do is cut the time of when something happens and their users are experiencing any sort of a problem, to them knowing about it and being able to solve it. I think if you have to choose one thing, that should be it. And that's what we work the most as well. But I think that's really the biggest one. Another thing that we see kind of really working for our customers, but that more and more people are trying to address, is alarm management. So what this means is coming back to the scale of a serverless application, having hundreds of resources, having different types of monitoring data. Then how do you, it's really hard to map out all of the possible scenarios when something can go wrong. And another challenge is to actually continuously have alarm coverage for them. For instance, if you have like 20 SQS queues, if one of those 20 perhaps has a high delay because of the consumer cannot consume as much as is being paid into the queue and there's a delay, or your API gateway failure percentage or like error percentage is increasing, then to have coverage for each one of those different scenarios across all of the different managed services is a really big problem, and organizations are spending time implementing this, but it's hard to do and it takes a lot of building. Also, I think tooling can scan for performance and cost inefficiencies and not efficiencies. So identifying slow performance, increased cost, and inefficient use of resources, inefficient kind of bundling together of the Lego pieces, if you will. So I think there's room for continuous evaluation of the system. And also the tooling should enable a team to learn and make informed decisions by continuously collecting data about incidents, making it possible to understand and document incidents and responses to them, and over time really educating the team and making sure, kind of maintaining the way that the incidents are managed inside an organization. So we have worked on this problem for over 3 years, and our approach to this is based on three pillars that I will go into now. This isn't really specific to Dashbird. I think that this is how we believe generally a kind of a monitoring and observability platform or approach should look like. So the first piece is centralization of all data about your system. So in our case, we collect everything about, like, from logs to metrics to tracing data to configuration data, and connections between resources, how they are configured, how those configurations change over time, and kind of try to offer a single, really easy to use platform to access all of the data. The second part is failure and threat detection. So we try to automate and pre-build for any scenario that can happen inside your application. So if you, like, from a delay, from a code exception, from like a misconfiguration, we try to cover the entire spectrum. The third part is the well-architected and best practice checks. So there's a lot of opinions in the community, a lot of like the well-architected framework in AWS, but also a lot of different white papers that outline things like how your resources should be tagged, how they, how you should have detailed monitoring and logging enabled, what should be implemented as alarms, all those kinds of things. So to continuously check for all of those. So those are kind of the three pillars that we think collectively make up this kind of a perfect setup for a monitoring or kind of just that enable you to operate a production application. Quickly going into all of those three, I won't talk about too much product specifically here. But the first part, the first pillar, is all about understanding how users perceive the application and basically democratizing all different aspects of the data. And kind of the way we do it is we don't just provide one bucket for logs or a log analytics service, for example, but we also filter out meaningful events from the logs, and we correlate those logs with tracing data, with metrics, and then give you a full picture from an account level into a transaction level, into how different resources interact with each other. So kind of you can look at the data from any angle, and you won't have to kind of build this data pipeline and data warehouse yourself. And this makes it really easy for organizations to kind of measure and understand changes and the cost and the service quality over time. The second thing, as I mentioned, is the failure detection. And here we really try to abstract, automate, and reduce the know-how necessary to accumulate in a team. So imagine you're adopting API Gateway for the first time and you're going to use Lambda for the first time and SQS queues. Then really each one of those services can have really specific failures to that specific service. So in Lambda functions, you can have throttling, you can have code exceptions, obviously, you can have timeouts. It's really hard to continuously monitor for all of those in CloudWatch, to build your own alarms. And it's hard to understand the root cause of different issues. So a lot of what we do is trying to equip teams with the with the product of undifferentiated heavy lifting in failure detection and alarm management. And the third part is continuously checking for best practices and trying to get a list of actionable things that are wrong with your application that could be improved. For instance, can you upgrade your runtimes? Are you over provisioned or under provisioned? Is something abandoned? It's not being used. It might be a security risk, and kind of all different types of best practice checks that look at not just the configurations, but also monitoring data, look at different historical alarms, and try to give you a kind of pillar by pillar score and how to improve it. So what we've noticed in our customers, what it kind of gives you over time is three things. It increases the reliability and the iteration speed, so you can build much more faster if you have confidence and if you have the ability to quickly react to things, quickly assess changes, and kind of always one place to look under the hood and get a good answer. The the second point is basically the why serverless is so popular. It enables you to focus on the customer by taking away the heavy, undifferentiated lifting. And we feel this is also what we do in the monitoring and kind of operational excellence area. And we enable you to basically achieve the best practices across the industry. So like the latest standards, the latest like most efficient things to build your application. And we kind of try to educate the team that is building the application. So that's it from me. I'm happy to take questions.
Thank you so much, Taavi. That was an awesome talk. My team's actually been looking at the well-architected framework quite a lot recently, so it was very informative for me as well.
Awesome.
I was quite curious, though. How far does tooling get you, and how much of this is cultural and education for the development team?
Yeah, that's a good question, because like there are, I would guess like 50-50 between what you can actually do with software, and like the other 50% is just like the practices of an organization, the processes, like continuous evaluation of like your infrastructure and kind of the incidents and like measuring. So a lot of it is like just reconfiguring your team as well, and being mindful of that.
And if your team is interested in like learning more, are there any good resources that you can point people towards to do further reading?
I think there's the well-architected framework. I know it's a bit long. If you don't want to read that, read the Serverless Lens. I didn't put the link. I can. I'm sure like everybody can find that, but the Serverless Lens for well-architected. There are, I think, presentations about it as well in different formats. So I would recommend this the most.
All right. Thank you so much, Taavi. It was good to have you. I'll let you go now. And thanks everyone else for tuning in and watching the first meetup for the year. If people were interested in the courses by Homeschool that I mentioned earlier, I'm just going to send a link in the chat to make it easier for you to find. And also, if you want to get more serverless news before the next meetup, Theodo, the co-sponsor of this, also runs a weekly newsletter. I'm going to send the latest issue of that as well for people if they want to read. Otherwise, have a good evening and we'll see you next time.